For years, the desktop computing landscape has been defined by a massive, frustrating compromise. If you wanted absolute earth-shattering power, the kind of performance that handles complex three-dimensional rendering, multi-stream 8K video editing, and massive machine learning workflows, you had to accept a giant, power-hungry desktop tower. You had to sacrifice an entire corner of your desk to a metal box filled with spinning fans, thick cables, and a power supply that sped extra electricity every time you hit the render button. On the other hand, if you wanted something small, minimalist, and elegant that fits seamlessly into a modern workspace, you had to settle for severely limited mobile processors, the rest of thermal throttling, and a machine that starts choking the moyu into a rattertans alongside heavy crew valkishi. The industry told us they've signed in power were want in a pern and physical streetals. And in the highly classified silicon design labs of Cupertino, a massive architectural rebellion has been quietly taking shape. Apple is not just preparing to update their smallest desktop computer. They are engineering a device that is designed to completely shatter the laws of thermal efficiency and redefine the absolute limits of ultra-compact computing. This is the real, unvarnished story of the upcoming Apple Mac Mini M5, a machine that is secretly being built to turn the entire desktop industry completely upside down. To truly understand why high-end creative professionals, software engineers, and data scientists are in a state of absolute frenzy over the specific release, we have to look past the surface-level aluminum shell. We have to look at a monumental shift happening at the physical atomic level of silicon fabrication. For the past few years, the entire semiconductor industry has been running full speed into a brick wall known as the limits of the 3-nanometer processors known. Engineers have been struggling with intense heat generation and power leakage as they try to cram more transistors onto a traditional chip design. But with the introduction of the M5 system on a chip inside the next-generation Mac Mini, Apple is about to become the first company in the world to commercialize a revolutionary 2-nanometer manufacturing process. Think about the sheer scale of a 2-nanometer innovation. It is not a simple speed bump achieved by overclocking an old architecture. This is a complete structural rebuilding of the silicon foundation. By shrinking the manufacturing gates down to 2 nanometers, Apple's silicon teams are packing tens of billions of additional transistors into a piece of silicon no larger than a postage stamp. When you increase transistor density to this extreme degree, the physical systems that electrical signal have to travel between the central processing unit, a graphics processing unit, and neural engine drops to near zero. Early supply chain benchmarks revealed that this monumental shift allows the M5 chip to deliver an astonishing 20% leap in single-core performance, while simultaneously slashing power consumption by a massive 35% compared to previous architectures. In the world of desktop computing, a 35% drop in power consumption while increasing raw speed is completely unprecedented. It fundamentally alters the math of small form factor computing. It means this tiny aluminum square can run at absolute maximum performance for hours on end without generating the massive thermal choke points that plagued every other compact computer on Earth. But a revolutionary